So the first lesson in Unit 4, using graphs to relate two quantities, which basically means can you look at a graph and match it up with the right information that created it. All you need to do is match up the pictures. Take a look at Getting Ready in this box on page 234. There are 3 containers on the right. There are 3 graphs on the left. If you imagine filling each one of these with water, which graph is going to go with which container? Well, first check out what's on the x-axis and the y-axis. Each one has volume on the x-axis. Each one has height on the y-axis. So, this one and this one. This one, volume increases more quickly than height does. On this one, height increases more quickly than volume does. So, which one of those is going to go with which one of these? Well, think about it. If you put water in a narrow cylinder, height is going to increase much more quickly than volume does. So this graph is going to go with this cylinder. If you put water in something that looks like a hockey puck, volume is going to increase much more quickly than height is. And, as you probably figured out, this one's a funky shaped one. So the graph is going to be funky shaped. Once the water gets up to this level, then volume is going to increase and height is going to slow down, which is exactly what happens here. Height stops going up so quickly while volume increases. Make sure that you understand this. Look at these pictures. This is important. It's easy, but it's important. So take your time, make sure you're good with it. Take a look at this graph in problem 1. This is called air in balloon. Here's time, here's volume. So why do you think the graph looks like this? This shows volume increases over time, and then volume stops increasing for a little bit. And then volume increases over time, and then volume stops increasing for a little bit. Volume increases some more, stops. Volume increases a little more, and then volume just drops back down to nothing. I wonder why. You think. Yes, you are exactly right. As the balloon gets blown up, the volume increases. And then you take a breath, and time passes, but the volume doesn't increase. Volume increases a little more while you blow in the second breath. And then take in a breath, put that air in the balloon, take another breath, start to put more air in the balloon, and then the balloon pops. Boom! Down to no volume. You have just properly interpreted this graph. Got it, number 1, on the top of page 235. There are 2 graphs. Letter A is a graph labeled board length. What is the length over time? Problem B is June cell phone cost. Here's the cost on the y-axis. Here's the minutes of calls on the x-axis. You take some time, think that through, and then come back and check with me. So, problem A. What's the first thing you notice on that graph? There are 3 drastic changes in length. Take a look at the graph again. Make sure I'm right. 1, 2, 3. Yeah. What else do you notice? The changes happen, drastically. I think I just said that. That is shown because you have that straight line as time goes on. So what do you think is happening to this board if the length is changing all of a sudden? The board gets shorter over time. So yes, the board is getting cut. What you need to understand from letter A is this is showing how the board gets cut. Take a look at letter B. The cell phone cost. What can you figure out from looking at the graph? The cost starts out steady, doesn't change at all. One flat rate. Then the cost starts to increase only after a certain amount of time. Then it rises steadily. What can you figure out from this? Well, looks like someone used more minutes than the plan allowed, because that's what happens. Problem 2, they want you to match up the data in a table like this one with graphs like these. I'm not even going to grumble that this is a multiple choice one. So, you are allowed to download a video from the website. The table shows the total number of downloads after 1, 2, 3, and 4 days. Which graph, over here, matches this? First thing you check out, days. 1, 2, 3, 4. That's pretty steady. So you look at these graphs and you say, okay, well that could be 1, 2, 3, 4. Those are all evenly spaced over days. That one makes sense. Those are evenly spaced over days. That one makes sense. That's fairly evenly spaced over days. This one, that's evenly spaced over days. Okay, so that actually didn't help us at all. I guess we better look at the second column. Total downloads. The first day, 346. By day 4, we're at over 10,000. So this is a very quick increase. We more than double, we actually about triple, right? Between day 1 and day 2. And then about triple again between day 2 and day 3. And then more than triple between day 3 and day 4. So we need a graph that is going to show us dramatic increase, and this graph shows a very steady increase, so that can't be it, which you might have guessed because somebody put an X in the book. Alright, let's take a look at letter C. This shows starting with a lot of downloads and then it kind of levels off. So that doesn't work. We don't want one that levels off. We want one that goes up. Maybe like this one, which shoots way up. Let's take a look at this last one. This one starts with a high number of downloads and then decreases. So this is our only possible match, even though I didn't put any numbers on this graph. This is the only picture that matches the correct shape for this table. Page 236, problem 2. A chart showing sunscreen use. And you have to figure out which graph goes with the chart. You work on it. I'll wait. Okay, I'm not going to show you what's written in my book because I think it's more helpful for you to look at this. First, uses changes steadily. And notice it starts at 0. So this dot is plotted directly on the y-axis. Does that all move fairly steadily? That one? Not so much. There's a lot more space between 0 and 1 than there is between 1 and 2 or 2 and 3. So I'm not sure that letter B is a good start right away. Letter C, those are fairly evenly spaced. Now let's take a look at the amount of sunscreen. We start with 5 ounces and then we go down by a lot or by a little. Are we getting close to 0? Well, let's match it up. We already got rid of B, so all we have to do is look at A and C. A takes us right down to 0. Are we at 0 here? We are not, which makes A a bad choice. Let's take a look at C just to be certain we're thinking properly. This starts up at 5 and then moves down, definitely, but not a lot. Letter C is your answer for number 2. Okay, I'd like to draw your attention to this wisdom on page 236. When you are creating your own graph and figuring out what goes on the x-axis and what goes on the y-axis, put the independent quantity on the x-axis. Put the dependent quantity on the vertical axis. And then, there's a helpful note here, time is almost always your x-axis, because time moves regardless of what happens. So that is an independent quantity. All right. Notice there are no numbers on this graph except for the zeros right here where the two axes meet. This graph entirely tells the picture through the way this line is. A model rocket rises quickly, slows to a stop as its fuel burns out, falls quickly until the parachute opens, and then falls slowly. Go through that again. The rocket is lit, or whatever, ignited, whatever they do to get it started, and it shoots up very quickly in height. Then at some point, it stops rising, and instead gravity takes over and it falls quickly. but then the parachute opens and it still falls, but it falls more slowly. I would like you to tackle number 3. I'm not sure that you need to see my answers for number 3. I think that you can work through this on your own and show your picture to me at your next math class. You are swinging. You move back and forth and swing higher in the air. You swing slowly to a stop. What is your graph going to look like? Then, this is reasoning, not necessarily a separate problem, but letter B is if you jumped from the swing instead of slowly swinging, how would the graph be different? I will tell you that you should have time on the x-axis and height on the y-axis. Then, last but not least, see, number 3, draw me a nice picture. Do the lesson check on page 237. It is only 4 problems, one of the shortest lessons ever.